You've got to decide whether to use medians or means. If you can use means, I would use them. So if the data are reasonably symmetrical, use a mean, or if you've got a large data set, but if the distribution does look quite odd, and what you could do is get the median and the mean and see if they differ a lot. But if it looks quite odd, it might be that the mean isn't the best summary statistic. Another thing to think about, which we'll be talking about when I come on to statistical analysis, is that sometimes a transformation of the data can make it more normal. A common one to use is to take logs. If you've got something where you're counting things, for example, numbers of cells, by taking logs, it can lead the distribution to be more normally distributed. And of course, there's other transformations you could do, like taking the square root of the data, or I don't know, more sophisticated ones that might make the distribution look a bit more symmetrical. And so I've just talked about single samples, but sometimes you're interested in summarising the differences between groups. And of course, you could just take the difference. It's quite straightforward to get a difference in means or a difference in medians, but it's getting the accuracy of that difference which is a bit more difficult. And I haven't really said much about this because when you get to this stage of if you want to get either the standard error for a difference or the confidence interval for a difference, you'll probably be using a statistical package to do that. But I've just put the formulae up here, so if you want to, you can do it by hand. If you had a difference in means, then the standard error is simply going to be the sum of the standard errors squared for the two means, sum it together, and then take the square root. And as I've said, that's often obtained after a statistical analysis. I think people often prefer to just present the individual means with their standard errors if they're just doing a simple summary. But if you do want to give a mean difference with a standard error, then that's how you can calculate it. The only thing to note is that sometimes you get paired groups. So for example, if you have a set of animals and you take a measurement before treatment and after treatment, so you've got two measurements on the same animal, then that data are paired. So what you would do then is take the differences for each animal and then simply get the standard deviation for the differences and calculate the standard error from those differences. So you're just simply getting the standard error of the differences, so you don't need this formulae. Unfortunately, if you want to, you can calculate the difference in medians, no problem, but there's not a suitable measure of accuracy for that difference, unfortunately. However, if you were in the position of having paired data, you could again work with the differences of the individual values, get the medians for those, and then get the interquartile range that we've just looked at, or the range, based on the differences. So you can do that if you want to then, but unfortunately if you've just got a difference in medians between two unrelated groups, there's not a suitable way to measure the accuracy of those medians, or that difference in medians.